we're going to talk about using exponential and wall functions for these finance equations. Some you've seen before, and some are going to be some new equations that you haven't seen before. And this is, I just copied this from your book, and it makes me laugh because it says, why do you need to learn this? The mathematics of finance is the science of letting your money work for you. Valuable information indeed. Right? I thought it was really cheeky. Makes me laugh. But there's lots of stuff, and if you go into finance, right, a lot of people want to go into something with finance, there's lots of pre-made programs that figure out loan payments and mortgage payments, but behind the program is the math that we're going to do today of figuring out what's the better deal, and that is kind of an important thing if you're talking about putting money somewhere. So I have some formulas for you, all right? So the first one is just interest compounded annually, and so look, I saved you lots of writing. It says if a principal P, and yes, principal, talking about principal money is spelled the same as principal in the principal's office, is invested at a fixed annual rate R, calculated at the end of each year, then the value of the investment after n years is A equals P times 1 plus R over N R to the n power. Hold on, don't write that. There's one that's more complicated. One plus R to this. Okay. So if you know what all these mean, P is how much you start with, the principal, R is your interest rate, and N is the number of years, you're only compounding it once, right? Annual rate means it's only doing once a year. And so look at this this first one. Find the amount accumulated after investing a principal of $1,500 for 6 years at 7% interest. This is why I've been working on you using your calculator all chapter, because you have to use your calculator on this, whether you're just plugging it in or we're going to solve stuff in a little bit. But you got to be comfortable using your calculator. Also, I'm missing calculator still, so please check if you happen to maybe what Alice wants, because I can't keep losing calculators and not covering the test days. So just check it out. Yeah. But this one's really easy, right? I just plug it in. Find the new amount. I'm going to say 1,500 times 1 plus, I just write 7 here. No, I write 0.07 for 6 years. That should look like the population growth and decay equation that we did back at the beginning of this chapter, where we had the initial population and then the rate of growth or decay to power, right? That also works for that. Funny thing. They make fun of me how I throw them, but that's because I throw them so you have time to catch them. I try to throw them and also so that if it does succeed, really nice thing about my calculators is you can see what you're typing, and you should be able to type this in all at once, right? And we're talking about money here, so round to the nearest cent. $2,251.10. Like that. It's going to be more complicated as we go along. Questions about that? Look like a question. Okay, so most things are not compounded just once a year. They're compounded monthly, or they're compounded quarterly, or they're compounded daily, or, I don't know, savings accounts are compounded quarterly. So the formula that I normally think of is more complicated than the compounded once a year. It's compounded K times a year. So it says still principal P, R, rate, but now we're compounding K times a year for T years. So instead of just saying 1 plus R, we're going to say 1 plus r over k, where k is the number of times a year. And instead of just raising it to the t power, you have to raise it to the kt power for the number of times a year times the number of years. And that works for the other formula, right? If k is 1, that's why I had to think about it for a minute. If k is 1, you get the formula I just gave you, so you don't really need to remember 2 formulas, because if k is just one time a year, you just plug 1 in there. But I wanted to show you why they don't give you 2. So when you read these problems, you just got to figure out what numbers you're plugging in. What we're going to do in a minute is we're going to be solving for k or solving for t, because we can do that now that we know how to solve log equations. But you got to pay attention to what it says. And this one's just written out in words, compounded 4 times a year. But quarterly would be 4 times a year. Monthly would be 12 times a year, right? So you have to kind of sometimes figure out what k is. And this one, you're investing $1,500 for 6 years at 7%. And this would be investing in stuff that you're not taking the money out. You're not adding more money in. It's just you put $1,500 in one time. 6 years later, you take it out. And this would be what you would get. So again, kind of a calculator heavy problem. My advice to you is show me what you're typing in your calculator. So is this the same problem on the last page, except for now we're doing it 4 times a year instead of 1 time a year? So now we're going to say 1 plus 0.07 over 4. And then it would be to the 4 times 6, and this is where you got to be careful typing things in your calculator. For me, I would just type 24 in my calculator. But I'm going to show the number up here. But if you're going to type in your calculator raised to the caret 4 times 6, you have to put that in parentheses on your calculator, because your calculator does order of operations. And if you just put caret 4 times 6 without parentheses, it's going to take it to the 4th power and then multiply everything by 6. So very different answer, which is why I want you practicing as we go through here. That you get the same answer that I did. Divided by 4 to the 4th power. I got $2,274.66. So on the last one, only compounded once a year, we got $22.51. Not that much more money, right? How much for next year? Okay, so this kind of just summarizes what we just wrote. Compound interest, all right? If they give you compound interest problems, your 2 formulas are, I'm going to write this one again. A equals P times 1 plus R over K to the K's power. And I'm not going to write those words in the test. But then we also have this idea of what is interest is compounded continuously, right? What would K be if it's continuously? Because this is a long proof of where it comes from. But that's where E comes in. I bet you remember this one. Or A equals, Mr. I'll call it right. A equals E to the power. And we're going to talk about, I'm going to give you these formulas on the test, but I'm not going to tell you what they are, right? I'm just going to give you the formulas, and you have to know when to use each one, right? So I'll give you this equation, I'll give you this equation. How do you know when to use it? If it says continuously, you use the E. If it says compounded so many times a year, then that's when you know to use that equation. So, find the amount accumulated after investing $1,250 for 6 years at 5.4% compounded continuously. Right? That continuously is my key word there, but I'm just going to take E to the 0.054. Times 6. Again, be careful typing this in your calculator, because both of those things go in the exponent. So on my calculator, when you hit E, it automatically sets it up for you with the parentheses. Don't close that parenthesis until the very 1728.3. In my college algebra book, it had a really cool way of introducing the PERT formula of talking about that the definition of E can be shown that if you take 1 plus 1 over n to the nth power, where n goes to infinity, that will always equal E. So that's why if you talk about it compounding continuously, like over and over and over and over and over, right? Like how do you compound more than every second, right? That you actually get E. It was kind of a cool definition of where E comes from because I'd never seen that introduction before. And that's how you get E. So like 1 plus 1 over 1 to the 1 plus 1 over 1 over 1 to the 2, you get. Okay. We could have done all this pretty easily before logarithms. So what we're going to do is we're going to be solving for other things that are missing. Right? So this is the instead of just plugging numbers in. There's a couple of those. Joelle invests $8,000 into a retirement account with a 9% interest rate compounded monthly. How long will it take until this single payment has grown in her account to $16,000? So this is something that people go to investment people and ask them, like, how much money do I need to be saving for retirement? Tomorrow we're going to talk about what most people do is they don't have $8,000 to just go into an account and never touch. Most people are putting in monthly amounts and trying to get retirement. We're going to talk about that tomorrow. It's more complicated than this one. But the same idea of how long will it take if I need $16,000 for that to get there. So we're looking for time on this one, right? So you have to know where to plug this stuff in. Compounded monthly means I'm using the 1r over k to the k power. And for me, right there, when I see how long, I know I don't know the time, but that means I should know every other variable to plug in here. So I should be able to go through this problem and figure out where to plug all the numbers in. So I'll give you the formula. You got to know when to use it. You also have to know what the letters represent so that you can know what to plug in. So I'm starting with $8,000, so that's my E. What's my A in this problem? Do I know? That's the new amount. I want 16,000. We got a 9% interest. That's yeah. And we're compounding monthly, so what do I put in here? 12 to the 12 power. Right? So before, in the beginning of this chapter, when we were solving equations, we were guessing and checking, or we were graphing on the graphing calculator, kind of see where things intersected. But now we can actually solve this just by doing algebra. So step 1, I'm just going to divide that 8,000 over, right? That's just going to give me 2. Also, I think we could just type that in my calculator. I'm going to put 1 plus 0.09 divided by 12. And I get 1.0075 to the 12 power. I need to solve for t. What do I have to do so that I can get this t out of the exponent? Let me solve equations with a t up in the end. X up there. Why do you just go to that? How do we solve equations like this? We ln both sides, because when you ln both sides, you can pull that out front, right? So that's what we're going to do over here, too. It's not as pretty of numbers. So I'm going to ln, or if you prefer log base 10, like I'm going to say ln of 2 equals, tell me if this is okay. I always just automatically pull it down. So I write 12t times ln of 1.0075. And that's just because that's what I want to do, right? Like if I ln this, then I can pull it out front. So I always do that in the same step. Can I solve for t now? And it's kind of up to you and how you want to do it. We could do it in 2 steps. We could do it all in 1 step. If I want to solve for t, and this is all multiplication, I just need to divide, right? So we could just divide by 12, and then we could divide by ln of 1.0075, or we could do it all in one step. And divide by 12 ln of 1.0075. I guess we gotta get that out. But if you're going to do it all at once, again, I feel like a part of this chapter is getting better with our calculators. Is that when I divide by 12 times ln of 1.0075, order of operations says that you multiply and divide per month, right? So if you just type in your calculator 12 divided by, ln of 2 divided by 12 times ln of 1.205, it's not going to give you the right answer. So just going to divide by 12 and then multiply everything by that ln. Which means we'll take ln of 2 divided by, and then tell it that you want all that on the top. Right? And that's where sometimes the newer calculators have that fancy button that you can kind of show it, tell it what the fuck was a lot easier. But parentheses become really important. This is where I think showing work is really important, because if you type something in wrong in your calculator, I can see that you had that, but then something happened on the calculator. I got 7.7305. Did you get that? Anybody need calculator assistance? Okay, so here's where we have to be exact. Okay? This is where we talked about at the beginning that we could be kind of nerdy and we could change this, right? That's 7.73 years. We could change that to months and days and all of that. On these problems, you have to change it to the next compounding. Alright? So if this compounds monthly, we need to say 7 years and whatever that next month would be. So this is where it's not just cutesy nerdy to do it. You have to be able to change 0.7305 years and know that you can multiply by 12 months. And that would be 8.8 months. So what would the next compounding be? Would it be at 8 months or would it be at 9 months that would happen? It's going to happen at 7 years, 8.8 months, but it only compounds every month. So we say 8 months, or should we have to go into the next month and say 9 months? 9 months. 9. You have to round up, because at 8.8 months, right, like if you said 8 months, you wouldn't quite be at 16,000. You'd be pretty close. So you would want to say 7 years, 9 months. If it just said compounded yearly, you would say 8 years, because you have to round up. Okay, so you have to kind of think about that, of how it's compounding when you're doing this. That's exciting stuff, right? So I like to give you questions about doubling your money and tripling your money. And people always think that there's not enough information, right? So if I give you this that says, what interest rate compounded monthly is required, required for an 8,500 investment to triple in 5 years. So same equation, right? So I'm going to be quiet for a minute. I'll write the equation up there. See what you can plug in. If you know what's going on. I really don't think I even need to give you this formula, but I do. Because I feel like if you give it simple work, you write this enough that you just I know that's 12, and I know 5 years, so I know that. Do I know A? Because why? I'm just tripling it, so 2 options. You could just triple it, or you could even just say, well, if 8500 is what I'm starting with, and I triple it, I could just say 3 times that starting amount. Or just triple it. Now, this is kind of like the last one, only I could have given you this problem before this chapter, because we don't even need to know how to solve exponential functions to solve this. We're just solving for r, right? It's kind of weird, but we're just solving for r. So I'm going to divide by 8500. We're telling nice. Same thing if you took 3 times 8500 and you divide by 8500, you're just going to get 3. And 12 times 5 is the 60th power. I don't need to ln both sides on this one. Because, I mean, I guess you could if you wanted to. But you don't have to, because there's no exponent up there. Right? But, I mean, you could, and you could pull the 60 down from it. That, I guess. But how do I solve this equation? How do I solve that equation? I take the square root of both sides, because the square root undoes a squared power. So what could I do on this equation to solve something to the 60th power? I could take the 60th root, right? When's the last time you took the 60th root of something? Over the weekend? So, I could take the 60th root of 3. And if I take the 60th root of 1 plus r over 12 to the 60th power. And I'm not going to use my calculator yet, because the 60th root of 3 is not going to be a pretty number. So I'm going to wait to the end, alright? If you like to use your calculator as you go, please use a lot of decimals, because if you round too early, then you get a different answer than me. So I'm just going to leave it at the 60th. So this cancels this out, right? So I just get 1 plus r over 12 equals the 60th root of 3. Then can you solve for r? What's the next step? Divide by 1? Subtract 1, right? Because that's just adding. And then what would I do? Multiply by 12. So I think I'm going to have 12 times the 60th root of 3, all minus 1. Right, just like some good old algebra here. Now I'm going to go to my calculator. And on my calculators, it's second and the caret button. It looks like this button. Every calculator is different, but mine looks like that. It's the x root, because we don't really think about taking over the square root of the cube root. So you can take any root. And you just have to tell the calculator what root you want to take. So you have to hit 60, then you hit this button, and then you hit 3 to tell it that it's the 60th root of 3. A lot of parentheses going on in there, right? So be careful as you're doing this. And let's see, we're looking for an interest rate. So it's going to be a decimal. So if you don't get a kind of normal interest rate, then you know that maybe something's gone wrong. If I don't have to put parentheses by that 3, that's 1. I got 0.2217. Did you get that? Interest rate, so if we change that to a percentage, that's saying that if you want to triple your money in, 5 years, you have to have a 22% interest rate. The only thing that ever has a 22% interest rate is a credit card. which means if you're trying to invest money, you're going to have to invest somewhere else, or you're going to have more money, or do something differently, because there's not going to be anything that gives you a 22% payout on that. And so that's kind of on that. Question on that? Anybody can check it out? All right, so what? Determine how much time is required for an investment to double in value if interest is earned at the rate of 5.75%. Again, quarterly salty, I mean, the only time I would use the first one is if it says compounded. Continuously. It seems like we're missing a lot of information on this, right? Because it just says for an investment to double in value, so they don't tell me what I'm starting with, but they do tell me the interest rate is 5.75, and quarterly means 4. Take 12. Three, 4. 4 times a year, right? 4 times 2 is 12. Every 3 months. And 4 times 2. Yep. It's okay. If I start with P, how much will I have when I double my money? Which means they don't have to really give you what to start with if they tell you what they want you to end with, right? If we want to double it or we want to triple it, if it helps you, make up a number to start with. It doesn't matter, because every time you'll be left with 2. Like if you say you start with $500, you double it, you'll get 1,000, and when you divide that over, you always get 2. Start with $1 million. Double it, you get 2 million. When you divide it over, you always get 2. So you don't have to know the principle if you're just trying to double it. You can just say it, and then you got 2. When we do half-life stuff, same thing on that. Like we don't have to know how much we start with. If we know the half-life, we know we end with half of it is left. So, all right. So I'm gonna let you do this, right? It just finds out. I always divide this, like I always do this in my calculator just so I don't have to do plus. And I just write all the plus. But this is the big idea with exponential functions. We know now that we can log our own both sides and we can solve that. So it's just like the same thing. I feel like it gets very redundant as you listen for something it does, because I'm always just plugging it in, holding both sides, dividing it over, making sure I say it in my calculator correctly. But setting it up, knowing which one to use, making sure I'm into my calculator correctly, all really important things. Making sure my answer makes sense with the problem, really important. Tomorrow we're going to talk about car payments. And I always do a question about figuring a car payment. I don't know what it said, like $7,000 car, person said this price, what would the monthly payments be? People give me answers like $8,000 a month, and the car only costs $7,000. That doesn't make sense. People tell me that their car payment is 25 cents a month. That doesn't make sense either, right? Like you want to make sure your answer is reasonable with the problem that you're solving. And so although maybe it's harder to sort a problem, it's easier to know if your answer makes sense as opposed to if it's just confusing. And for me, like I said, every time I think it's 14, so in 1.014375. So I'm just going to divide all that over. Over 2 divided by 4 times ln 1.0147. and then you just want to make sure you're typing in correctly. You don't want to wait till the test and then find out that you typed in all the things in your calculator wrong, which means also, maybe good advice, use the calculator that you're going to use on the test so you can make sure you know how to use it. Did you hear that? Again, when we're talking about time on these, we are compounding it quarterly. So quarterly means, right, you get statements at 3 months, 9 months, and then at the end of the year. So when you give me this answer, we can change this to months if you want, but 0.14 of a year is not very much. It gets definitely less than the first 3 months. So like I'm going to say, I know that I can just say that this is 12 years, and although 0.141 years is not 3 months, it only compounds every, like, quarterly. Does that make sense? So you have to say the next time it compounds would be at 12 years, 3 months. Like, that's 1.692 months. But it doesn't compound at 2 months. It only compounds at 3 months, 6 months, 9 months, 12 months. Yes? Other questions about this? Tomorrow we're doing investing and like mortgage payments, car payments, and I'll tell you the formulas are really, really ugly. That's the reason I give you formulas on the test. Because if it was just these two formulas, I probably would be really mean and not give you formulas. But tomorrow, same idea, just a lot uglier formulas. Did you have a question, Lindsay? So this is 3-6 day 1, 2 through 12 even. I think those are just typing in your practice formulas, like not hard ones. Maybe like just finding out like those should be just all straight calculator using the formula. But then 21 through 39 multiple equations, those are, some of those are going to be where you're solving for the interest rate, you're solving for time. You're solving for how many times it uses compounding. You're solving for something else where you're going to have to elevate both sides or involve both sides. On 33, 36, and 39, they give you a table and they ask you to find the missing values. Don't freak out on those. Look at it, put it in your equation, and figure out ways to solve it. I'm sure we'll do it tomorrow. It always know that